Okay, welcome and hello everyone. My presentation is on a novel coke drum bottom unheading device with an integral feed inlet. This is a new invention that we just got patented a couple of months ago that I would like to share with you. So first, I'm going to talk about the background, the history of bottom coke drum unheading. Then I'll talk about the different feed inlets that we've used. And finally, we'll talk about this new patented device, which is the subject of the presentation. First, let's talk about bottom unheading. So the classic way of unheading a coke drum that goes back to the middle of the 20th century is to have a bottom bolted flange that we manually unhead. Now, as we learned over many decades, this is not a very safe operation. It has happened before over the years where the crew would be unbolting or loosening the bolts, and then they get accidents and they get burned and injured. So this manual unheading process, which was used for decades, was found to be not the safest way of unheading a coke drum, just simply because you have tons of hot coke with hot water and just standing right on top of that flange, and so it is a safety risk. In 1990, we had a swing away unheading device that made the process safer, where somebody can perform the unheading from a distance as opposed to being right under the coke drum. That device was used for a few years, but it had its limitations. So a more advanced way of unheading started in the 2000s. We had the simple gate valve that was invented. This is a sketch from the patent, or one of the patents that describe this device, which is a very simple device. You have a gate valve that has an opening, and by sliding the gate valve in or out, you can open or close that bottom head of the drum. So this was a major step in improving the safety of coke drums, coke drum operation. So that was the simple gate valve, and then we had the double disc gate valve that was also patented in the mid 2000s. I don't have an exact date on that, but it's somewhere in the middle 2000s. It's similar to the simple gate valve, except that it has more elaborate sealing mechanisms with double discs. The two valves they basically perform the same job, and they both are a huge improvement in safety of operating the coke drums. And now, 20 years since the introduction of the gate valve, most refineries have them. or plan to have them in the near future. Now let's go to feed inlets. So back to that original design from 1950, the coke drums were fed using a centralized inlet that was integral to the flange at the bottom of the cone. That integral arrangement was a simple design, and it gave us a very desirable feature, which is that the flow of fluids was centralized. So when we fill the drum, the flow goes right up in the middle and produces a symmetric or axisymmetric temperature distribution. Of course, when we go into quenching, the process is maintained, and the flow channels that form during fill are utilized to quench the drum in a symmetric manner. The result of this symmetric flow is that the structural integrity of the cone was typically maintained. We didn't have a lot of problems with cone failures at the time. Also, tilting of the drums was relatively uncommon for the most part. It was reported, but it was not a very common occurrence. In addition, blowouts, which occur due to the non-uniform cooling of the coke body, were not common at the time. Now, what happened is when we utilized these other types of unheading devices, whether it's the swing away or the slide valve, the gate valves, when we started using those, of course, we gained a lot on safety, but now we had to find a different type of inlet because we cannot keep that inlet in the same location because we're not using that old design anymore. And because of that, the vast majority of drums that received those automated valves utilized a side inlet instead of the bottom centralized inlet. Now, we'll talk about the different varieties of these feed inlets, but what is common for all of them is that we had to add a spool on top of the gate valve. So the bottom of the coke drum now will need to have a spool with the inlet, and then we add the gate valve at the bottom of that spool, as you see in this typical drawing. So the traditional single inlets, they come in two varieties, either a straight inlet, which is 90 degrees angle, it's at a 90-degree angle with the axis of the coke drum, or one that is slightly angled upward, which makes a a, an angle other than 90 degrees. It usually goes like 120 or something around that angle. The problem with these traditional single inlets is that the flow of fluids, the flow of coke, petroleum coke, as it when it comes in as residue or fluid, it goes in and then goes on one side of the coke drum cone. As you see in this flow, in this sketch, that uh, the arrow shows that usually we get asymmetric flow into the drum, which means that temperature distributions are not axisymmetric. They're not uniform around the circumference of the cone and quite often in the whole drum. Now, there is another type of single inlet, which is a refractory-lined single inlet. And this is a patented design by Chevron. The idea of this design is to allow the flow of coke or residue to go in and circulate in a barrel, and then after it circulates, it rises up, supposedly or typically in a uniform manner. And to minimize the temperature differences and thermal gradients in that section, in the spool, there is a refractory that you see here in this patent diagram. This refractory that's indicated by number 18, it insulates the metal from these high temperature gradients and therefore minimizes the damage to that spool and minimizes the likelihood of leakage at the bolts or at the flanges, the top and bottom flanges of the spool. Now, experience with this specific design is mostly limited to Chevron coke drums. As I understand that this has been made available to for licensing recently, but I don't want to go into any details. I would just have to refer you to the guys from Chevron to give you more details. Now, the performance of this design has been recently shared by Chevron engineers at a previous RefComm meeting in Galveston and at a coke drum forum in Houston last March. So I would have to refer you to those presentations to get more details about the temperature distributions and the result on coke drum coking and bulging and tilting. The other variety of replaced inlets is the dual inlet design. And of course, it comes in the two basic designs, which are straight and angular. As you see in the graph, the idea is when you have two opposite inlets, flow will equalize, and we get a mostly symmetrical flow upward into the drum. This design has been used for many years, and experience is, there's a lot of experience with it, but it seems from published information and papers that we've seen at various conferences, it seems like the experience is mixed. Some users have never had any issues with it at all. Some users have complained about certain problems with leakage and distortion in the cone, but it appears that it's dependent on the design details, on who designed it and how it was made and the science behind it. The third type of dual inlet is a tangential design, which you see in the bottom left corner. This tangential design, it aims, or the idea is to have a vortex type of flow inside the cone, which again allows it to go up in a more uniform manner. This particular design is patented by Exxon, and I would have to refer you to them for details on the design and any installations and performance. Now, a solution to the asymmetric flow was introduced a few years ago with the retractable inlet, where flow is actually going through a centralized nozzle that goes inside the coke drum in the spool, and it has openings that shoot the flow upward at the center of the spool. This retractable inlet, in combination with the gate valve, they ensure that you have an automated unheading with a centralized flow in the drum. Now, the device has been utilized in several refineries around the world, and it is becoming more common. Now we'll talk about the new combined valve inlet. So this is a patent that we got, a patented design that we got on this novel approach, which is to try to combine both devices in one. Instead of having a separate valve and a centralized inlet nozzle, a retractable inlet nozzle, what we did is we thought that if we can combine the two, we will get significant benefits from installation, operation, and maintenance. And we'll talk about those in a little bit. So this design, the way it works is that what you see here is this is a drawing from the patent, and basically we have an exterior box and an interior box. The exterior box is the one shown with the number 300. This exterior box has centralized openings. You see with the number 304, top and bottom. It's just a box, an empty box with those two holes. And then there is a side nozzle, you see with the number 302. That combination, that opening and the side nozzle, they match a cylinder and an elbow on the interior box. The interior box is shown at the bottom, and it's the number 320. And so if you take the sides, this is a closed box, but if you take the sides, what you'll see inside is the elbow with marked by 322 and the cylinder 324. Now that box, that interior inner box, which slides axially inside the exterior box, is moved by an actuator, which you see as 330. And that actuator's, its job is to slide the inner box to line up one of the two, either the elbow 322, which lines up with the side nozzle 302, or it lines up 324, the cylinder, with 304, which are the openings at the top and bottom. And so when we are in fill, you want the elbow activated. And when we're in emptying stage, you want the cylinder 324 to be activated. So this is more of putting those components separately, and you see the inner box at the bottom both closed and open in green. You see the outer box in red, the actuator in blue, and the bottom of the cone in gray. So when you put all of this together, during fill, we move the inner box to the position you see here, where flow goes, the residue flow goes through the inlet on the side, the nozzle on the side, goes through the elbow and shoots straight up, which gives us the centralized flow that we are seeking. When it's time to unhead and empty the drum, we slide it back to the position where the inner cylinder lines up with the openings at top and bottom, which looks like this. So these are the two positions of the valve. So the advantages of the combined device, from an installation standpoint, we need less space because we don't have to have that spool anymore. This is a major problem, especially for older units where there is very little space below the drum. And this is a major issue for a lot of units where they try to use the gate valves and they can't because of the lack of space needed to install the valve and the spool with the side inlet. That is one of the big advantages of this design. Of course, the other one, it's less costly because there is less work to do. There are less modifications. There are less devices to install and maintain. From a maintenance standpoint, we're basically dealing with one device instead of two. So that should minimize the maintenance effort. So you don't have to take apart two separate devices and deal with two separate potential issues with each one of the devices. And then lastly is reliability. One of the main apprehensions that I have heard from clients about the idea of having a movable device inside a coke drum is reliability issues. Anytime you have this high temperature environment, very viscous fluids, and then you have a movable device, something that actually moves inside to fill and to retract in and retract out, there's always this question in people's mind, well, what happens if it gets stuck? What happens if it doesn't work? You know, what happens if you get a failure in it? These are all concerns that I've heard repeatedly, and I appreciate and understand. So a combined device that I just showed you does not have that limitation. There is nothing moving inside the coke drum. The device is completely external to the drum. Both the filling and the emptying are performed through that same valve. Finally, I just want to describe the status of this. This is, you're getting the heads up because this is a patent that was issued just 2 months ago. It was issued in February 2021. And we are in discussion with several valve manufacturers. As you may know, our Houston Engineering is not in the valve business. This is just an idea for a design that we believe will have significant advantages, but we are seeking manufacturers to take the idea and turn it into a field-ready product. When an agreement is reached, we will be looking for the first site installation. So those who are operating company engineers, if you are interested in utilizing or trying this device when it becomes ready, please let me know, and we'll put you on the list, and we'll see when it comes out. We'll let you know when. And work out agreements and get you with the valve manufacturer. With that, I want to recap. I talked about the background and the history of bottom coke drum unheading. I talked about the different types of feed inlets that we have used for coke drums over the last several decades. And finally, I talked about our new patented unheading device with an integral inlet and discussed its potential advantages and talked about its status and future outlook. I understand that we will have a question and answer session afterwards, in which I would be glad to take any questions that you may have. These are my email address, phone numbers that you can contact me directly, or you can send me a question on my RefComm profile if you're unable to go to our question and answer session. With that, I come to the conclusion of my presentation, and I thank you for your interest.